All right, so nodes. Last time, this idea of a linked structure, but I was really emphasizing that this in and of itself is not an abstract data type. It's just really a linked structure is like this aggregate that doesn't exist in a class, but it's this like aggregate entity that is a series of linked nodes, right? And the nodes that we're going to deal with are singly linked nodes. They're very simple nodes that have two fields. Data, which is some reference to some field. It'll be a reference because it's going to be generic, and generics need to be objects, and therefore they're references. And the other field is going to be a reference to a node of the same type. Okay? So, if we have this linked structure, I want to be clear that right now there are 4 nodes on this screen. The boxes, okay? This baby blue, vomit green, cyan's got a little more pop to it.
It's like sad teal.
Teal, yeah, sad teal and black. There we go. That's the nodes. This right here is a reference variable to a node called head. It itself is not a node. It's a reference to a node. All of these arrows are references. So there are 1, 2, 3, 4 references to nodes and 4 nodes, but head itself is not a node. It's a reference to a node. Keep that in mind. If here I were to say head equals null, I lose reference to this node, which means I lose reference to this node, which means I lose reference to this node forever. All right? So here's my current situation. If I wanted to say, okay, let's insert things into this linked structure. If I had an array, how would we insert things into an array? Well, if I wanted to add something to the end of an array, you just go to whatever index is like, pretend this is sufficiently large. And I've got like A, B, C, D in here. If I want to add to the end of this array, well, you just go to the end index and, okay, there we go. Right? Easy peasy. If I want to insert in the beginning, though, well, it's kind of a pain. We got to move D down. We got to move C down. We got to move B down, then A. And then we can add our X, right? To insert at the beginning. And inserting in the middle is like somewhere in between the two, right? Move as many things down as we have to make room. Okay? So, with a reference to the head of a linked structure, how would one access the first node's data? Imagine I have a variable called head that is a reference to a node. How would I get its data? Well, I would say something like head.data, or get data, whether it's a public field or we need an accessor method, whatever. But the fact is I have a reference to an object, and then from that object I can request its data. How would I get the second node's data? Well, looking at this, I have no direct way to access the second node, but I have an indirect way. I can say, hey, head, what's your next? What's your data? Pretend the data's down here. That's how I would do it. The third, well, I would say, head, what's your next? Well, okay, head, what's your next? What's your next? What's your next? Next. I could keep asking, because each next will give me a new node object, assuming it exists. It could be the end, and therefore it's like referencing null, which means, okay, there's nothing there anymore. But I can keep asking next to move down this chain. How do I access a predecessor, though? Let's say I magically have reference to this node. Okay? Let's say, okay, I've got head. I create a new reference variable called C, and then I say C equals heads next next. So C references this. Let me draw that out so it's perhaps a little clearer. And I'll just do dot. I don't know if you can see that. Whatever. There's nothing there. There. References nothing. And in here, I'm going to put like A, B, C, D. This is to like give the nodes a label. We can think of it as their data. Really, their data would be a reference to some object somewhere else. But for ease here, I'm just going to draw the letter A inside that node. And I have head, which is a reference variable to that. If I were to say, hey, C equals heads, next, next, C is equal to heads, next, next. Well, conveniently, C references C. Okay? Let's call that X, actually. Let's say X equals heads, next, next, just to not create any ambiguity. When I say C, what do I really mean? Okay? So far, so good. Can you see that over there? Yeah, mostly at least. Okay, great. So let's say now I have a reference to C. How do I get the predecessor?
You just nod.
In a roundabout way, I can by being like, start over, I guess. But I mean, that's like,
But not with justice.
exactly, right? Like I can only move one way. I can't go backwards. If I really need that thing, I'd have to start over and be like, okay, is heads next the thing I care about? Is heads next the thing I care? Yeah, and then I guess we could do something like that. But in this state, I can't do that. There's no way to get a node's predecessor like directly. Yeah.
Would X be another head?
X and head. It depends on what you mean by that. So let me answer this question two different ways. At the end of the day, head is just the name of a reference variable that gets me to a node. X is the name of a reference variable that gets me to a node. Now, as far as we know, there might be another node referencing this, meaning that this is the head of some list. But you'll notice that every list, like, there, look, it's a list, right? I'm trying to block this, right? And X is the head of that list, right? So, oh, it's the head of a list. Yes, because, I mean, I actually have no way of knowing if anything's in front of me. So as far as I know, this is the head of this list. This is the head of this list. This is the head of that list. Does this remind you of anything we learned about 161 by chance? That's fine. We'll come back to this later. I was kind of hoping it would, though. Anyone want to take a wild guess?
I mean, my mind just like sets in dictionaries somehow.
Dictionary, okay. Yeah, I see what you're saying, but no, not where I'm going. It's recursion, right? Well, this is a list. Oh, this is a list. And then this is a list in terms of, and this is, and so on, right? But don't worry too much. We'll get back there. Now, how would I add something to the front of this list? I want to put the letter Y in the front. How do I do that? I want to add something in the middle. How do I do that? Well, these are rhetorical at this stage. At the end, how do I do that? What if I want to remove something from the front, from the middle or the end? Removing from the front is actually the easiest of all these things. So adding to the front. So let's say this is our current situation. All right? I've got the answer here, but like if we go down here, we'll have the answer. But I want everyone to take a moment and think about this, because at this stage, I'm confident that most of you can come up with the idea in your head about what the steps are. I don't need to teach this to you. You kind of probably already know. So let's say I've got head. It references this yellow node, yellow, gray, black, okay? And I want to put the node referenced by the reference variable node, this blue one, in the front, such that the order would be blue, yellow, gray, black. How do I do that? All we have is I can ask head, what's its data, what's its next. I could also set it, though. I also could say, hey, head, your next is this thing, or your data is that thing. I'll give you a hint. You don't care about the data right now. You only care about the next references. Same with node. You could be like, hey, what's your next? This is your new next, something like that. All right? So this is the state. I want to have it such that head is such that the order of the things is blue, yellow, gray, black, and head references the beginning of the list, where the beginning would now be the blue box, blue node. How would I do that? Take a moment. I'm going to give you 30 seconds to ponder this and come up with a solution. Feel free to talk amongst yourselves. I don't want an answer right now. It's great if you have one. But talk amongst yourselves, work it through, convince yourself. You can retrieve. You can pretend nodes, or we can think of nodes as being very mutable. Okay, we can access and modify the data that they're referencing. So, who thought of this? Set head to reference the head, the new head, and then have node reference the yellow thing. Well, who said anything about a stack? It's just a link structure. Who thought of that? Well, you'd be wrong. Because the order really matters. If I were to say head, you reference node, I lose reference to the yellow thing, and that's as good as gone. Rats. So we actually have to be very careful about the order that we do things. What I ought to do is say, okay, node, your next is the thing that head references. Okay? Then head, you reference node. There. I know I was being kind of nasty because chances are you said, you may have thought of it that way, but when I said it in the reverse order, you're like, yeah, whatever. But it matters. So I was trying to trick you. Yeah. Well, no, I would have to say that. I would have to say, node, set your next to be what head is. And remember, this isn't head. I mean, it is in the sense that the name of the reference variable is head, but what it means is that thing. So if I were to say, hey, node, your next is a reference variable to this thing. Then I would say head, you equal, not head, I'm modifying what head is, not what head's referencing, anything about what head's referencing. So I would be like, head, you equal node. I don't say head, your next is the node. No, that would break everything. So the first step is, hey, node, set your next to head. And then head, you equal node. Not set your next to node, but you equal node. Setting heads next to node would make this arrow point back here, and then we'd be in a load of trouble. I mean, maybe it wanted to do that, but we didn't want to do that. Yeah?
So the idea is we don't break the head before we create another head?
Because if we lose, it's about not losing reference to anything that's important. If we lost reference, if we did this first, pretend this arrow didn't exist. If we said head, you equal node, and that doesn't exist, nothing references this. That means the garbage collection is going to come along and be like, you're delete, delete, delete. We can't access it anymore, so it's gone. We just have to make sure. Yeah. Like if I'm holding like a chain, and I want to add something to that chain, okay? But something's tugging on that chain, right? But I'm holding it because and I want to add something to it, right? The steps are going to be take the thing, put it on that chain, and then I can let go. If I go, oh, it's gone, right? If I want to hook something onto this chain, and it's getting tugged, I have to hook it before I lose it. If I let go of it, I'm screwed, right?
Better start running.
Better start running, yeah. So adding to the middle. So let's say we magically, yes?
Is head referencing node or the blue square?
It references the thing. Remember, node is not a node. It's a reference. It is a memory address. The memory address might be like 14. So what do I put in there? 14. Has nothing to do with this box, but everything to do with what this box contains. So you're thinking, oh, is it a chain? No, it's not. It's just, they're reference variables. Yeah. So adding to the middle. Let's say I somehow magically have, okay. I want to insert here, such that the order is going to be this one, this one, this one, this one, this one. Okay? Light blue, green, what do we say, teal-ish, sad teal, blue, black. That's the order we want. How do we do it? Well, first, we need we could do this by using heads, next, next. But let's say we get a reference variable to like here. Okay? We'll call it like insert after or something. All right? Current, here I call it. Okay? So, if this is the situation, how can I insert it? What are the steps? Take 30 seconds and think about it. What are the steps? You got it? Maybe.
Well, he added current, so I don't know if he wants one that one called teal, or you can call it sad teal current if you wanted to. No, or you can call it that. No, it's sad teal.
All right, who's brave? Yeah. So set this next to be current next. Exactly. Did anyone go, okay, set currents next to the new node? Did anyone do that first? Because if you did, you should feel terrible about yourselves. Because as soon as you did, we lose reference to the poor little black box. And we're in big trouble.
We tell blue to point to itself.
Exactly, we'd be in big trouble. So we have to say, okay, nodes next is currents next. Then currents next is node. The order really matters here. So nodes next is currents next, and then currents next is node. And we're happy. Adding to the end, by the way, is the exact same process, right? You figure, pretend, for example, that that black box is actually null. The same steps would apply. The new nodes next will be what this current node's next is, null. And then this node references that one. It's the exact same thing. It's like a special case of insert into the middle. It's so special that it's not even different at all. Yeah?
Do you have to put null to signify that it's
Well, at the end of the day, I don't care. What are you asking? In terms of like inserting at the end, or in terms of like, if I'm inserting at the end, setting it to null is, like explicitly setting it to null is kind of redundant, because if this was, let me draw it. A, B, C, null, right? If this is current, I'm going to reference it as X, and this is node, happy face. Okay? I want the order of this link structure to be A, B, C, happy face. Okay? So I would say, hey, X, or no, node, your next is current's next, which is null.
But wouldn't happy face already have to point
We don't actually know. I mean, probably. It really depends, right? Assuming it was a new node, what if it's from somewhere else,
Okay, yeah.
right? You know, but very good observation. Yeah, it's reasonable to think in a lot of cases it would be. And then current, your next is now that happy face. So this, there. So the fact that it's like nodes next and currents next, well, it's null, or maybe it's another. Who cares? It's whatever was next, whether it was null or another node. We're going to set this new node to reference whatever came after. All right, removing from a link structure. Well, how can I remove? I kind of spoiled it briefly. But how can I remove? I want to remove this one now. Sad teal. I want it to be such that the order is yellow, gray, blue, black. How can I remove sad teal?
Make head reference the next.
Exactly. Head, u equal heads next. So heads next is this thing, and then we assign head to that. There. Just like that. That's it. Removing from the front is the easiest. Removing from the middle. Now, I'm showing you an example where we have two reference variables being used. And you might feel as if using two reference variables makes it easier. And if that's true, more power to you. But in general, you can do this with one reference variable. Let's say I want to delete current. Okay? How do I delete it? Well, previous next is now going to be current's next. Boom. I could have also have said previous next is previous's next's next. That would have done the same thing. The benefit of this is I don't lose reference to this thing. And maybe I want to return it or something, whatever. I can do something with current now if I've removed it. So there is some value there. But, you know, in general, we don't need the current. You also might notice, well, hold on. Now we have two things referencing this box, right? This one and this one. What's going on? Doesn't matter. What's the list referenced by head? What's the list referenced by this? The fact that they're shared is a funny little quirk, but, you know, it doesn't really matter. Because what's this one's previous? It doesn't know, right? It doesn't know. You might be like, well, it's that one or that one. As far as this black box is concerned, maybe it's the head of a list. It doesn't know. It thinks it's in charge. Removing from the end is also, again, imagine that this one's next was null, right? If that black box was null, it would work the same way. Pretty neat. Now, you'll notice that sure we had to go search through where and find where we wanted to remove. That was required. But unlike the array, we didn't actually have to shift any data really around. We were able to just kind of like shove it in where we wanted to put it, which is kind of neat. Any questions about those ideas? So this was all talking about nodes in a relatively abstract way. So like, what does a node class really look like? Well, this is what it would look like. Public class node, type T. It's got some data T, some node of type T called next. A constructor. You notice I have two constructors here? I didn't need to do it this way. I could have done it another way, whatever. I did it this way for fun. A default constructor that just calls, it just changed to this one such that the data I'm giving it is null. Or I've got a node where I give it some data. So I have a choice. I can either create a node where it's created where its data is null, and we can do whatever we want with it later. Or I can give it some data, and it creates and it just sets its data automatically. That's all. Why? Because.
And do you get type-related shenanigans later if you make it null, because the node doesn't know what type it should reference yet? Cause any problems?
No, it'll know because when you make an instance of a node, it'll know that it will be of type T. You would have to specify. There's going to be integers in here, but null is valid.
You just don't give it one.
Yeah.
So it's integer null.
Yes. I mean, it's Null is null, but you can kind of think like that for sure. So here we go. And then we have a get data. And now we have an example of a mutator. I ranted about these are yucky and bad. We don't like them. Well, for something like a node, maybe we use them. We could make our node class immutable, where whenever you wanted to set the data, you'd make a new node. But that makes a lot of extra work. So get data returns something of type T, right? The data. How do we know it's type T? Because that's what it is. But we've got set data. And set data is a mutator, a setter, where it takes some data of type T and it mutates this is data. Yeah?
Now, given that we can get the data and set the data, is there a good reason for it not to just be public?
So let me come back to that in 1 second. We'll get there in 1 second. And you'll notice that the return type of this is void. Why? Well, it doesn't need to return anything. We could have had it return a Boolean, like was it successful? But what would that even mean? That doesn't really make any sense from a design perspective. If you really wanted to, sure, more power to you. But set data, and it sets it. Now there's ambiguity, data, and this data. Well, we resolve the ambiguity by saying, well, this class's field data and the argument, or sorry, the parameter data, they're separate, right? Same name, but they're different. Yeah?
Is data current in this case?
No, data is just some data. I've got a node, and what do I want in there? The letter A, the number 77. I don't care. It doesn't matter. Then we have the same thing for next. Get next returns some node of type T, which is its next field. And set next will be a reference to a node of type T, and we update it, return type is void. You might say, why not, to your question, why not make them public? Right? Why not? It feels like you made them public with extra steps, right? It feels like, okay, you made it private, but you just opened it right up. And you're entirely right. You can go and find node implementations where they are set public because it just makes it easier, right? The benefit, for lack of a better term, is, so the getters are one thing. With setters, you could do additional, like the value of having a setter is that you could put additional checks in there. Like maybe you want to have your implementation such that you can never set your next to null. So I could say like if next is null, like do nothing. If it's not, then update it, right? So you can add additional logic within the setters if you really wanted. In this particular case, I'm not, so there would be a reasonable argument to make these public because it doesn't really matter. But this is how we did it.
You could also have both.
You can make them public and have getters and setters. Yeah, but then you would be like, you could bypass the setter and then be like, well, what was the point of restricting access? We could play this game. These are design decisions at the end of the day. Yeah?
Once a node has been set to have like a certain kind of data, and say it's like an integer,
Yep.
can it then be set to contain a string?
No.
Stop on it?
Once it's created, because you consider the fact that, here, I'm going to actually just take this whole class right here. Boop. There. New node. There. Okay, we've got our node class, right? Consider that within here, if I make one, I would say a node of integers, my node, now it's called node, equals a new node with nothing in, 55, right? Great, cool. When I do this, this is the same as me writing this, okay? It is created, and as far as the node's concerned is, whatever data I get has to be integer. Why? Because it says right there. Now I know we don't have to say it, but it will know that diamond operator, right? Which again, I always find amusing because it's not even like, it's not a diamond, it's just an empty whatever. right? But it will be an integer. If you really want to be able to change it, one, don't do this, but you could make it type object, and then anything you put in here has to be an object, and an integer is an object, and a string is an object, so you could totally do this. Don't do this, though. This kind of defeats the whole purpose of having like the nice strongly typedness, right? The alternative would be to like deal with it, make a new node of a different type. Yeah. Yeah?
Yeah. So a node can point to a node of a different like subtype, right? Like, is that fine?
Of a different subtype.
Like if you have an integer node, its next can be a string node, and that's fine? Or will it
No,
No.
because it must be
type T?
type T. Good question, though.
Okay,
So,
so if you use something other than T, like a different generic type variable, it would be that, or?
it would probably say x, and then it's going to be like, what is x? And I would need to define x up here, but then I would need to specify, yeah.
So you can do it, but it's work.
We could do it through the object way for sure. We don't ask those questions right now, okay? Now, if we had object, and then here I say ASD equals node. Now, why is it unhappy? Because, yeah, so it's very picky, right? You'd be like, well, a node of objects is a node of integers. Not quite. I know you might feel like it should be, but there's a lot more rules we would have to specify on the generic types.
Could you cast it?
I could, but then I think if I were to run it, it might get mad.
Well, we'll find out.
Ah.
Or you need an object, and they're not integers. This is already an integer.
Of node. Yeah, but because usually that's an upcast. Why is I'm sure this makes perfect sense, but not right now. Sorry, it makes perfect sense why it doesn't make sense, but I can't rationalize it right now. Either way, we're looking for trouble if we start doing that type of stuff, anyways, right? In general, like we're like, I get it. A good computer scientist is always like, how much can I break it? Right? Like, what are the rules? And if those are the rules, what can I do? If that's the question you're asking, good for you. Just not today. All right? Cool. Other questions? So here's the node class, yeah. So for the sake of having some fun, let's say, okay, so for I, let's make like, okay, 10. And we're going to want to start it at like 1. And we'll set this at 0. Okay. And then we could say node dot, oh, and then we're going to say, okay, node integer c, okay? And c equals node. That's okay. There we go. And then c dot set next to a new node of I. Okay, cool. Let's run this and make sure it's valid. Come on. All right, so it didn't get mad. So what did I do? What did I do? Take a moment, look at this code. You definitely are equipped to be able to answer this question, but I am pushing you, right? But when in doubt, what does the code say? Here. Just as a note to help. No. I missed something. There. This is critically important. Now it's far more interesting. All I did before was set the heads node to point to something, a node that contained 1, and then immediately reset it to point to a new node that contained the number 2, and so on and so on and so on. So this is far more interesting now. This line right here is doing two things, right? It's creating a new node with the data I in it, and immediately saying, hey, C, your next is this new node that we just created. Usually, if I was coding this, I would have done this in 3 lines of code. I'd made the new node, then set it. I generally don't like lines to have multiple instructions in it, but I was lazy today. If it's a question, you can ask the question. I don't want an answer, though.
A question.
The question. What's the question?
I just want to know, why did we have to, why did we declare C and then have to do a new node later again and set next? I'm a bit confused because
We're going to work through it, and I think that'll answer your question once we work through the code. What's your question?
Why did you declare node and then C and then make C equal to node?
Because otherwise I would lose reference to head. You'll see. We're going to draw it. Okay? So, what does this code do? Let's start with the first line. Okay, we make a new variable called node. And it references a new node with the data 0 in it. I'm going to draw the 0, the integers inside the node, even though really it's a reference variable to an integer somewhere else. For simplicity, I'm just going to draw it inside of it. Then what do? I immediately make another reference variable called C and have it point there. Okay? That's where we are. Any questions so far? This is line 7 and line 8. I'm seeing like a few people going like, oh yeah, all right, I gotcha. Yeah, good. That's good. So what are we doing? For I, starting at 1 to 10. Why am I starting at 1? Well, first of all, the value of I is only being used to create a new node, and I already have 0 at the beginning, so I'll start at 1, right? So 0, 1, 2, 3. So first line of code in there, I'm saying, okay, hey, C, oh, that's this node. Your next, oh, okay, set my next to be, oh, a brand new node with the contents I in it. 1. And then C, you're equal to your next. Repeat the loop. Okay, hey, C, oh, that's this node. You reference a new node with the number 2 in it. And then C, you reference your next. This pattern of like something equals something.getNext, C equals C.getNext, that is your common iterating over a link structure pattern. C equals C.getNext. That's how we iterate down. Okay? Cool. Awesome. So at the end, what do we end up with? A link structure with the numbers 0 through 9, because of course we don't get to 10. Cool. Now, people were asking, why did we need that C? Well, because if we didn't, and we didn't have head, or what did I call it, node, and we just were like, well, C references that. Well, as soon as C moves to its next thing, nothing references this anymore. And it would delete, and it would delete, and so on. And at the end, we would only have a reference to a single node with the number 9 in it. Not very helpful. All right. Questions, thoughts, concerns, comments, anything?
I like it.
You like it. I hope you love it. Because we're going to be doing a lot of link structures. Yeah.
I would take marks though, because it should be current, right?
So, oh yeah, that's a terrible variable name. And node is also, right? This should probably be like head.
What if we found that it gives you
Head. Current. Now, you know how like one could argue, so I is a common shorthand for like, okay, if it's at an index or something, right? Or I iterating whatever I, right? But it's only an I. If it means iterate, why not call it iterate? You call it I. There would be people that's like C. Well, that's just like the common thing we use for like C for the current when iterating over a link structure. So if I took off marks and someone came to me saying like, no, and here's my argument for why I called it C, and they gave me that argument, I'd be like, okay, fine. Fair enough. I'm not gonna, like, that's a good point. But for the sake of like goodness, yeah, we've got that. Now what's it mad about here? That's a lie. It's a lie.
Big lie.
It's redundant. Oh yeah? Why? What? Yeah. See, this would be not good. See, look. IntelliJ is lying to me, right? Head is redundant. No, it's not, right? It's not redundant. If we didn't have head, this would be useless. So be careful. Those warnings and whatnot, it's just a heads up. It's not to do your job for you. It's to help and like augment your job a bit. Like, hey, that's redundant, and you have to be smart enough to be like, shut up. Okay? You're the one with the brains. This is just some basic if statements, right? So be careful. Anyways. And then, okay, what is this code doing? Well, the same thing, just with extra steps in a way that I feel is a little bit more self-explanatory, right? So what am I doing? Creating a head node called head, starts with 0. I print out its data because why not? Then I create a variable here called current node, sets it at head. That's going to be the thing to iterate. That was the C. And then I've got just a node reference variable here called new node that I'm using to create the new one such that it's happening in 2 lines, where in my example, I did it in 1 line. So that's why they have that extra reference variable. You might say, why did I declare it out here and not inside the loop there, right? Like, you declared it and then assigned it. You could have just put that in there. Yeah. And the compiler would have turned it back to this because you only need to declare it once, right? And then assign it multiple times. The compiler would have probably been like, yeah, it's whatever, just put it up there. So you might be like, oh, I like my code better if I define it. But no, this is better this way. New node, set the current, and then move down. And then what's happening here? This here as well. This is your common pattern of looping over a linked structure. Current node starts at the beginning. Current node is going to be the iterating thing. Well, current node is not null. Print out the data. Whatever we're doing in the loop is whatever we're doing here. We're just printing. Print it out. Current node is current node's next. Is it null? No? Okay, keep going. Is it null? And it'll go until finally current node will eventually, like we've got some giant list, and we've got some last node that references null. Eventually current node's going to be here. Current node equals current node's next. Its next was null. Is current node null? Yeah, done. This is the common pattern iterating over a linked structure. Get used to it. A common pattern for iterating over an array is like a for loop, right? Usually. For I from 0 to however many things are in the array. For a linked structure, it's this way. One may feel to themselves like, these 2 containers require 2 different ways to iterate over. Oh, okay, I guess I'll remember that, but it's kind of, we have to do it 2 different ways. Yeah.
Here, wouldn't C still point to the last thing? Because after you run it through your counter. Oh, wait. Oh, never mind. Sorry.
Yeah, cool. To clarify, we are at and now we're here. Okay? This is current node. I've iterated over a bajillion things, I don't care. Finally, I'm here, which happens to be the last thing. Okay? And I say, hey, is current node not null? Doesn't look like null to me. Print out its contents. Current node equals current node's next. This one's next is null. So it references null. All right? Now, we say, hey, current node, are you null? Yep. Or are you not null? No, I'm not null. And so we're done. Yeah.
So do you get something from the end of a link structure? Like if you want to get rid of the last thing in a link structure, do you just have the one before it reference null?
Like if there was a node here, and I want to delete this?
Yeah.
Well, yeah, that's what we did in the previous examples, right? Where we did it in a, because remember, it's the same as removing from the middle. This might be null, it might be another node, I don't care. But if I want to get rid of this thing needs to reference this thing's next. So your nexts is now your next's next. So my next, where I want this to point is going to be this one's. And then this disappears. Whether that's null or another node, I don't care, because this is going to reference something that might be a node or it might be null. If it was null, that means this was the end. If we ever get to a situation where you're like, delete this one. How can I delete this one if this is what I have? Start over and get this one, because you really need this one to be able to get rid of this one. Because this one has no control over what this one references. It can only control what this one references. So at the end of the day, I can't get rid of this one unless I have the one before it. Now, it's possible that we have that funny edge case where we have a link structure with one thing in it. And I say, delete the last thing. So this is a funny edge case, right? Where, oh, go to the thing in front of it and set its next to, oh, there is no thing in front of it. Ugh, how do I do this? Well, that's easy. Just, if C and head are the same thing, the head is the same as the end, which means, well, just set both to nothing. Yeah, right, there we go, cool. All right. Oh, what is this? Okay, and just warning, head is not a node. It's a reference to a node. I've got a giant warning about it. Read it, study it, ponder it, think on it. It's important, right? So, head is not a node. Head is a reference variable to a node. Head equals some node and head.set next to some node mean two entirely different things. This is head equals some node. That's what that does. Head.set next to some node does this. Two different things. All right, and we'll start with this warning next time. Have a great weekend.